Hi everyone. Today we have the second class for Surds. So today we discuss addition and subtraction of Surds. Before we continue or we solve the examples we have on the board, we need to understand that we can only add and subtract similar or like Surds. Surds that are similar, Surds that are alike, they are the only ones we add. Think of algebraic expressions or terms like 2x plus 3x. Yeah, 4y plus 3y. So when we say 2x plus 3x, we say 5x. 4y plus 3y, we say 7y. I hope it is clear. So how about 6x plus 3y? Do you think we can get 9x? No. 9y? No, because x is here, here is y. These are unlike terms. The variables are not the same, so we cannot add them except we say what? 6x plus 3y again. So the same thing applies here for sorts. If they are alike, we add them. Otherwise, we don't add them, we don't subtract them. So let's see what we have. All right. Now, I want to simplify here. The first thing we do is to check if the inner part, in fact, these are the irrational parts. Yeah, here we have root 3. Here we have root 3. They are alike. They are similar. They are like sorts. So we can add them. So adding sorts is the same thing we do like if we say 6x plus 4x. We don't talk about xx. Yeah, once we know we can add them, we say what? 6 plus 4. What is 6 plus 4? Is 10. This x, we just take 1. Sorry. We just take 1. That is it. So here again, once we know we can add them for being similar or like sorts, so what we have here is 1 plus 1, we have 2. So 2 root 3. I hope it is clear. Here again, root 3, that is our concern as to whether the sorts are alike. If the sorts are similar, yes, they are alike. So we can add them. So here we have 1, here we have 4. So 1 plus 4 is 5, 5 root 3. As long as you are adding or subtracting, these that are the same, you only take 1. Then you add or you subtract what we have in front of them. Is that understood? Okay. So here again, 6 root 5 minus 2 root 5. The most important thing is the irrational part. Here, the irrational part. Root 5, they are the same. They are similar. They are alike. So we can subtract them. Subtracting them, we consider what we have outside. Yeah, the rational part, not the irrational part. 6 minus 2 is 4. So 4 root 5. I hope it is clear. Okay, so here again, we say 3 root 6 minus root 6. Yeah, 3 root 6 minus root 6. Okay, so are they the same? Yes, they are the same. So being that they are the same, we consider what we have outside. We only compute, we only work what is outside. We add or subtract what we have outside. Outside here is 3, here is 1. So we say 3 minus 1 is what? Is 2. So we say 2 root 6. But there is something I seem to have forgotten to explain first. Before you add, although yes, we can add without considering what I'm about to say, but it is worth noting that make sure if you don't consider that before addition, after the addition, you have to confirm that this one is a surd and nothing like root 4 because root 4 will give us 2. The square root of 4 is what? Is 2. So don't forget that one. 5 cannot be reduced further. Root 6 cannot be reduced further. What does that mean? We cannot reduce 6 further because we only have 3 times 2 to give us 6. This is not a perfect square. This is not a perfect square either. So any number that cannot produce at least one perfect square for what the product, it means you cannot reduce it further. I hope it is clear. So 15 is just another. 15 we say 5 times 3. 5 is not a perfect square. 3 is not a perfect square. And there is no other number we can use as a product to give us 15. So therefore, 15, we cannot reduce it. It is what? A pure surd. So therefore, we can add or subtract where necessary. So outside here is 9. Outside here is 3. 9 plus 3 is what? Is 12. 12 minus 6. Only what is outside you add or you subtract. 9 plus 3 is what? Is 12. 12 minus 6 is what? Is 6. So we say 6 root 5. Sorry, root 15. I hope it is clear. Okay. Now let's come to something that we cannot directly add or subtract, and that is what you should be expecting for those who are preparing for exams. Okay, here is root 48. Do you think we cannot reduce 48 or we cannot simplify it further? Let's find out. The first thing we do, we say 48 divided by 2. Yeah, the numbers you test, the number that it should be tested, like 2, 3, 5, 6, 7, 11, 13, 15, 17. These numbers, the prime numbers, try them. Yeah, even if it's not a prime number, but number that you know we cannot reduce it further in terms of surds, that ones we try. Okay, now 48 divided by 2, what do we get? We get 24. These two, both, none is what? Is a perfect square. So try 48 by 3. 48 divided by 3 is what? Is 16. This is not a perfect square, but this is a perfect square. The most important thing, one must be a perfect square. So since you divide this by 3, it gives us a perfect square. So it means 16 times 3 will give us 48, where 16 is a perfect square. So we say 16 times 3 plus. Now we go to the next one. The next one is root 3. But root 3, we cannot simplify it further, so we just write that one. Then again, before I continue, if you have in a surd expression, you have one particular surd that is not reducible, you cannot simplify it further. Most times, before you even think of dividing this one by 2 by trying, go straight to what? 3, because this is among them. Most cases, the what? The surd you have in the surd expression that you cannot simplify further, most cases, it is what is possible that you will find in all the terms you have in the expression. Okay, minus 4. How about 18? Let us do even, how about 18? 18 divided by 3 is what? Is 6. 3 is not a perfect square. 6 is not a perfect square. So let's go back to 2. 18 divided by 2. What do we have? We have 9. 9 is a perfect square. So we say 9 times 2. Do not suspend the roots like this. It doesn't work at all. Make sure it covers this. So this one is a perfect square. What is square root of 16? Is 4. You send it out. 4 root 3. This is 5 root 3. This is 4. The one we have outside is 4. What is square root of 9? Is 3. That 3 has to come outside. But bringing the 3 outside, there is also another value outside. So the one outside multiplies the one coming. Square root of 9 is 3. 3 goes out. What remains in the root is just 2. So this is 4 root 3 plus 5 root 3 minus 4 times 3 is 12 root 3. So you can consider what we did here. So root 3, root 3, root 3. So all of them are like surds. They are similar surds. So we can add, we can subtract. But adding and subtracting, it's addition and subtraction is only done with numbers outside. So 4 plus 5 is 9. 9 minus 12 minus 3 root 3. Root 3, root 3, root 3, so we take 1. I hope it is clear. Okay, now let's come to the seventh example. Here is 4. 50. The first number we try is 2. 50 divided by 2 is 25. 25 is a perfect square. So we say 25 times 2. How about it? 8. Divide 8 by 2. What do we get? 4. 4 is a perfect square. So 4 times 2. 32. 32 divided by 2. 16. 16 is a perfect square. So 16 times the 2 you use to divide. So 16 times 2. So outside is 4. But the square root of 25 is 5. That 5 is coming outside to meet what? This 4. So the one that we are having outside multiply by the one that is coming outside. Square root of 25 is 5. So here is 2. This is 3. Square root of 4 is what? Is 2. What remains in the root is this 2. Square root of 16 is 4. That 4 comes out. I hope it is clear. So 4 times 5 is 20. Root 2. 3 times 2 is what? 3 times 2 is 6. Root 2. 4 times 4 is 16. Root 2. Okay, I'm sorry that I made a mistake here. I'm happy that I haven't sent the video online. Okay, this is 9 times 2. This 2 remains out, so it should be 2 here. 2 here, not 3. So once it is not 3, it is 2. So this one cannot be added to this. Cannot be added to this. Oh, this is 4 root 3 plus 5 root 3. So root 3, these two can be added. So 4 plus 5 is 9 root 3 minus 12 root 2. Can we go further? No, we cannot continue. That is the result. Yes, because this and this, they are unlike surds. They are not similar surds. So we cannot subtract them. So now we continue. Root 2, root 2, root 2. So all of them are like surds. So 20 minus 6 is what? Is 14. 14 plus 16 is 30. So 30 root 2. So I want you to try this and tell me what you have in the comment section. Thank you for watching. Don't forget to follow, like, share, and comment. Also subscribe to the YouTube channel.